All right, we are ready for another math video. Sure am. All right, we are ready for this. All right, got my Steelers shirt on, got my Kentucky hat. Those are my teams. Saw Kentucky play last night down in Greensboro. They won the first round of the tournament. Going to see them again tomorrow when they play Kansas State. Hopefully, they win. All right. If you don't know, my daughter is a freshman at Kentucky, and my wife went there back in the day. So by default, I am a big Kentucky Wildcats fan. All right. So this video might be played for years to come. So it might be outdated, but this is 2023 right now. It's actually the 18th of March, 2023. All right. Here we go. All right, we got a graph to the right. I changed it around a little bit from what you see on your page so I can see just number one on my page here. Vertex, we have to find first. If you don't know what a vertex begins with the letter V. The letter V looks like this. At the bottom of the letter V, if we put a dot on there, that would be the vertex. If we go up and do one the other way, that would be a vertex. These are kind of like humps. So it's the bottom of the hump or the top of the hump. All right, but that's the vertex, okay? These kind of look like U's, so it's the very bottom of the U or the very, very top of the U. That's going to be our vertex. So if you were going to put a point on the vertex in blue, I would put the vertex right there. And they want to know what is the vertex. So when they say what is the vertex, they want to know what is the coordinates of the vertex. If you don't know how to find the coordinates, this is how we do it. All right, so this is how we do it. We start in the middle. I'm going to start in the middle, put a little green dot right in the middle of our origin. You go to the left or right first. So the vertex is directly below number 2 when we go left and right first. So our first number is going to be 2. Then we're going to go down, and the number that it's across from on the way down is negative 9. Negative 9. So remember, go left and right first, and then go down. So we went to the right 2, and we went down to where it's negative 9. That is our vertex. Y-intercept. The y-intercept is where it touches the y-axis. So this is the y-axis. It's the vertical line that goes up and down. Where does this red parabola touch the y-axis? Well, I believe that it touches the y-axis right there. That red line touches the y-axis. Now that's negative 5, but we need it as a point. And how do we do a point? This is how we do it. All right, so to find this point that's in yellow, we start in the middle. Do we go left or right? No. So the first number is going to be 0 because we do not move left or right. But we go straight down and we're at number negative 5. So our y-intercept is 0, negative 5. X-intercepts. Well, if the y-intercept is where it touches the x y-axis, then the x-intercept must be where it touches the x-axis. All right, we're going to do a purple line across the x-axis. All right, and where does that red parabola touch the red line? I see one right here and one right here. All right, so how do we do those points? This is how we do it. All right, we start right in the middle and we go left. That's the first time we go left. How many times do we go left? 1, and that's a negative 1. We don't go up or down, it stays right there. So the second number is 0. Start in the middle again. We're going to go to the right to 5. That's our first number. Left and right is our first number. Then, do we have to go up or down, or are we right there on the yellow? We're right there. 0. Notice Anytime you have a y-intercept, the x is 0. Anytime you have an x-intercept, the y's are 0. All right, let's do axis of symmetry. Symmetry means everything's equal on both sides. This is our axis of symmetry right here. It cuts right through the middle of our parabola, and it cuts right through that vertex. Goes right through that vertex. That's our axis of symmetry. Our axis of symmetry. Man, my cat is outside. No, it's not my cat. It's my daughter's cat. I think my cat wants to come in over here. Let's see. All right. Come on, Boots. Let's come in here. All right. All right. That's Boots. Boots is coming in. It's my daughter Lexi's cat. Lexi's a sophomore, by the way. Get out of here, Boots. All right. Let me sit down. All right. So, axis of symmetry is that vertical line. If you fold the parabola over that vertical line, it would fold right on top, perfectly on top of itself. Anytime you have a vertical line, we talked about VUX a while back. VUX stands for vertical lines. They have undefined slope, and their equation is x equals something. So the axis of symmetry, because it goes through the 2 on the x-axis, and because the vertex has an x of 2, it's going to be the same thing. The axis of symmetry is x equals a positive 2. It's that simple. I know. You didn't think it was that simple, but it is. Domain. Well, this is even simpler. Domain, I'm going to give the symbol for all real numbers. Domain is the x, by the way. And the reason the domain is the x is because these parabolas here on this side, they keep going up and to the left, and this one keeps going right and to the left. So it's going to touch every x forever. If you had negative 100 here and you go up, this line will eventually touch it. I don't know where. It's going to be way up, but it will because it keeps going forever to the left. And this, if you had, let's say 1 million, I'm not going to write 1 million because it's too many zeros. If you're going to write 1 million on this, eventually you would go up and this red line would keep going to the right and you would have an X of 1 million somewhere where it would hit this line. So that's why all real numbers is the domain. Now the range is a little different. The range means the y's. So here's our y-axis in the blue, the highlighted blue. And if I go here and I go to the all the way down at the vertex, hello vertex. If I go down to the vertex and I go and I can go and I have a point here that touches -9. In fact, the vertex touches 2 negative and -9 on the y's. But if I go down to -10 and I go all the way across to the right, all the way across to the left, it will never touch at -10. It never touches this parabola at -10. So we're going to say the range touches at -9 and everything greater than -9. It touches at -9. That's where the equal sign comes in. And it touches everything above -9. Okay. So, and it always is a y. So y is greater than -9 for our range. All right. Increasing interval. Here we go. We're going to come in from the left side, all the way from the left side, and we touch our parabola. Okay, we stop right there. From there, we're going to go towards the vertex. We're going to go towards the vertex, which is going to be down. Okay, so this side, because we went down, this side is decreasing, and the other side is increasing. Now, the left side is always our less than side, and our right side is always our greater than side. So the increasing interval is when it's greater than, and we always say it's increasing when x is greater than whatever our axis of symmetry is. So x is greater than 2 when it's increasing, and x is going to be less than 2 because this was our less than sign side over here, and on this side it was decreasing. On this side it was increasing. Decreasing on the left, increasing on the right. Always use an x, and the number is always going to be our axis of symmetry. All right. Positive and negative intervals. All right. When we do this, okay, we are going to look for the hump. The hump. The hump gets the in-between treatment. So where is that hump? Is that hump below the x-axis? This is the purple x-axis. Is the hump below the x-axis? Or is that hump above the x-axis? So here's my hump. Okay, that's the hump right there. When I say hump, this is the hump. I'm drawing on the hump here, okay? That's my hump here, okay? The hump is below the x-axis, so that's going to be negative, okay? Negative gets the in-between treatment. When I say in-between treatment, my in-between treatment means less than, and x in the middle. And we're going to use our x-intercepts for this. Our x-intercepts was -1, and our other x-intercept was going to be 5. Excuse me, 5. So the negative interval is the hump here because it's below the line, and it's in between 1 and 5. Now the positive is going to be the others, but that's going to be separated. It's when x is less than -1 and when x is greater than a +5. You see how that's separate? And I put an end in the middle. Okay, that doesn't get the in-between treatment because those are two separate lines, okay, up here. Think of these as arms up here. They're two separate arms. I'm going to highlight them in green. Okay, green. Well, I shouldn't do green because I did green before. Yellow. I'm going to highlight them yellow. These are the arms over here. The arms are separated, okay? They're totally separate. So they get the end between them. All right, let's hit the next one. All right, we're looking for a vertex. I suggest you do this one by yourself and go as far as you can possibly go, and then play the video and see if you are correct. Okay, vertex. I want you to imagine where you would put a point on the vertex. Okay, the vertex is the very top or the very bottom of the hump. And we're going to put the vertex in purple. And what is the vertex? We have to find this coordinate plane right here. How do we do it? This is how we do it. All right, we're going to start right in the middle. I like to start at the origin, and I'm going to go left because I'm going to go right underneath my vertex, and I'm at -2. So that's going to be my x at -2. But then I go up to a +4. So this point here is -2 and +4. Y-intercept. Where is the y-intercept? And what is the y-intercept? Think about it yourself. Don't wait for me to tell you. Think about it. You got to think here. The y-intercept is going to be where the parabola, the big N or upside down U or the big hump, where this line touches our y axis. Okay, this is the y axis, by the way, the one that goes up and down. This is the x axis that goes left and right. So it touches right here, and it looks like it touches at the origin at 0, 0. The x intercepts. Well, where does this parabola touch the x axis? I'm going to go across here in green. That's the x-axis. Where does the parabola touch the x-axis? Well, I'm going to highlight that in purple right here at -4 and also at the origin 0, 0. So it touches at -4, 0 and 0, 0. Axis of symmetry. Okay, let's put the axis of symmetry as a vertical line. Imagine where it would go before I do it. And here is the axis of symmetry. It cuts right through that vertex. And the axis of symmetry cuts through -2 right there. And the vertex, the x of the vertex is -2. X of the vertex and axis of symmetry are the same. X of the vertex and axis of symmetry are the same. X equals -2. Domain. Well, what do you put for domain? All. Real. Numbers. All right, range. If you don't know the range, you should know that the range is the same as your y of your vertex. 4 is the y of the vertex, which means it touches as high as 4, okay? And does it touch everything above 4 or does it touch everything below 4? It touches everything below 4. So the range, because it's below 4, it's less than or equal to 4. Now, the increasing interval. Okay, we are coming in from the left. Okay, as soon as we touch the parabola, we are going to go towards our vertex. So let's go towards our vertex over here. And we go towards our vertex by going up. So this side, we are increasing over here, which means the other side, we're going away from the vertex. We are decreasing on this side. This side is always the less than. This side is always the greater than. So we're increasing when x is less than, and we're decreasing when x is greater than. And we always use our axis of symmetry, -2, -2. Positive, negative. All right, what are we looking for? That's right, we are looking for the hump. And the hump this time is on top of the x-axis, okay? Here's our x-axis, okay? So everything is on top of our x-axis here. So the positive side gets the in-between treatment. The hump gets the in-between treatment. And when I say in-between treatment, I mean what I just wrote with an x and a less than on either side. Now we use our x-intercepts, which is -4 and 0. When we have the other ones, the negative ones are going to be the arms. The arms are going to be separated. So we're going to, here's the one arm, here's another arm. They're separated. So we're going to separate this and we're going to say x is less than -4, our first intercept over here that we used, and x is greater than 0. All right. I think we're doing all right here. Next, they do not give us a graph with this one. So we have to use our noggins, all right? Our noggins. And when we use our noggins, we got to be thinking here. First of all, the x squared. If it's a positive x squared, which this is, it doesn't say negative x squared. If it's a positive x squared, the graph is going to look like a U. So it's going to open up like a cup, as Miss Wren says. All right. The vertex. If it opens up like this, where is the vertex? The vertex is at the very bottom. So the vertex is a minimum. The minimum means the very bottom. What is the y-intercept? Well, we talked about this a little bit. The y-intercept, if we draw a little graph here, the y-intercept is where the parabola touches the y-axis. And I just drew, well, let me draw it a little better here because the y-intercept is going to look a little different on this one. Okay, so anytime you have a y-intercept, you know what the x is of that point. So if this is the y-intercept, I know that when I start in the middle, I don't go left or right, so the first number is going to be 0. If your first number is 0, which means the x is 0, that means if I plugged in 0 to this equation, my answer would be whatever the c value is. Now remember, the a, and let me write what a is. A equals 1 here because there's no number in front of the x squared, so we can write 1. B equals a positive 8, and c equals 7. So if my x was 0 at this point and I plugged it into this equation, it would be 0 squared plus 8 times 0 plus 7. That would be 0 plus 0 plus 7. My answer is always going to be, the answer for the y-intercept is always going to be whatever the c value is, and that is 0, comma 7. Axis of symmetry. What is the formula for axis of symmetry? X equals opposite of B divided by 2 times A. What's B? B is 8. B is the number that's in front of the X. B is 8. What's the opposite of a positive 8? You have to watch your signs. All right, the opposite of 8 is negative 8. Okay, if this was a negative 8 here, if this was negative 8x, then the opposite of negative 8 would be a positive 8. We're taking the opposite of the sign that's in front of the x. Negative 8 divided by 2 times a. Now, a is 1, and 2 times 1 is 2. So negative 8 divided by 2, the axis of symmetry is, what's negative 8 divided by a positive 2? The answer is negative 4. That's our axis of symmetry. Now, in order to get the vertex, we take the axis of symmetry and then we just plug it in. We have to plug it in to our equation. And we do have an equation right here. By the way, all equations have an equal sign. That's what makes an equation. X squared plus 8x plus 7. X squared plus 8x plus 7. That's our equation. So if we know that the x is negative 4 for the axis of symmetry, we did say earlier that axis of symmetry that is going to be the x of the vertex. So the vertex is going to be negative 4, comma, something else. And we have to figure out what that something else is going to be. So if we know the x is negative 4, we are looking for the y. Well, we have an equation. And wouldn't you know, this equation says y equals x squared plus 8x plus 7. And if you know what the x is, you're going to plug it in right here. Okay, if you have a fancy calci, then it's easier. And you would do negative 4 in parentheses squared plus 8 times negative 4 plus 7. I don't have my calculator on me, so I'm going to try and do this in my head and not make a mistake. Negative 4 squared is a positive 16. 8 times negative 4 is minus 32. And then plus 7. We're going to get negative 16 plus 7. And we're going to get that to equal a negative 9. That is our y of our vertex. So instead of this question mark right here, we have solved the mystery. Mystery solved. Negative 4, negative 9 is going to be our vertex. Uno más. One more. All right. We have an equation, negative 2x squared plus 4x plus 6. Does the parabola open up or down? Well, how do we know? We're looking at the x squared, the number in front of the x squared. Is it negative? Well, it sure is. It's negative 2. That means the parabola is going to look like this, and it's going to open down. Where's the vertex? At the top here. The vertex is going to be a maximum here. We got a maximum for the vertex. What is our y-intercept? Don't even have to do a lot of work here. Think about it. What is our y-intercept? It's whatever our c value is, the number by itself. Let's list a, b, and c. A equals negative 2. That's the number in front of the x squared. B equals 4. That's the number in front of the x. C equals 6. That's the number all by itself, not connected to any letters. Now, don't get fooled here, okay? Don't get fooled because yeah, I pity the fool. If they switch the order on you and put 6 minus 2x squared plus 4x, your A still is negative 2, your B still is 4, and your C still is 6. Okay, it doesn't matter what order they put them. You can put them in the right order, but this is still going to be your C, the number by itself. This is still going to be your A in front of the x squared. This is still going to be your B in front of the x. All right. So the y-intercept, we always have a 0 first, and then 6 because that's our C. Axis of symmetry. We have to use our formula. X equals opposite of B divided by 2A. Make sure you're looking for your... Do this, don't do that, can read the sign. All right, we got to read the signs. On B, it's a positive 4. So the opposite of B is a negative 4 divided by 2 times A. That's going to be 2 times negative 2. What's negative 4 divided by negative 4? Because 2 times negative 2 is a negative 4. Anytime you have a fraction with the same number on the top and same number on the bottom, that's going to equal a positive 1, as long as the signs are the same. All right. So our axis of symmetry is x equals a positive 1. All right. Now, what's the vertex? Well, let's take a look at what our equation is. What does an equation have? An equal sign. Negative 2x squared plus 4x plus 6. Negative 2x squared plus 4x plus 6. And we'll put the y equals. So we have to plug it in. Plug it in, plug it in. We have to plug in this positive 1 anytime you see the x. So where this x is right here, I have to replace it with a positive 1. And where this x is, I also have to replace that with a positive 1. So it's negative 2 times 1 squared plus 4 times 1 plus 6. And we have negative 2. That's going to be because 1 squared is just 1. Negative 2 times 1 is negative 2. Plus 4, because 4 times 1 is 4, plus 6. Negative 2 plus 4 is a positive 2. 2 plus 6 is going to be 8. What did we just find? We found the y of the vertex by doing that. Okay, we knew the x was the same as the axis of symmetry. X of the vertex is the same as the axis of symmetry. We plugged it in and we got the y of the vertex. All right, I hope this helped. Later.